Dear participants, today's first session is on Multisim live circuit simulator. So I welcome you all for this second day of the STC. So before I start, just let me know how many of you are already using this Multisim live circuit simulator or the standard Multisim software. So you can type in chat box if any one of you is using Multisim live or Multisim software. Kindly write in chat box. So anyone who is aware of Multisim live software, kindly write in chat box. Okay, so I am assuming that no one is aware of Multisim live circuits of simulator. So I will explain accordingly that this tool is new for all of the participants. So this tool is more towards the electronics practical side. So using this tool, we can perform experiments related to basic electronics, analog electronics, operational amplifiers, and digital electronics. So as analog electronics is also there in electrical, digital electronics is also there in electrical, IT and CSE. So this tool is helpful for these branches. Even for other branches, if their teachers are interested in exploring these electronics circuits or digital circuits, so they can explore using this free online simulator without investing any, we can say, the resources, and it can be this particular simulator can be accessed anywhere, anytime if we have the internet connection. So let me share my screen. So to start with this Multisim live circuit simulator, first thing is that we must have we must go to the multisim.com website. So I will be demonstrating live this particular simulator. So there will be no PPT. So I will be explaining here in real time various features. So you can interrupt me anytime if you want to repeat any particular feature or any, if you want to discuss any point during the demonstration. So you are free to interrupt. So to start using this Multisim Live software, we need to go to multisim.com. So we can go through this Google, and we have to basically reach this website, multisim.com. So this Multisim Live circuit simulator is the online version or the cloud version of the standard Multisim software which we use in our labs. So this is therefore online spy simulation. So to use this Multisim Live, so we need to have one account. So let me again start from the first step. So if this will be the landing page for this multisim.com. So if you want to use this Multisim Live particular this tool, then we must have a username, one account, login account. So for that we can here, click here sign up for free, and then we can create our account. So this tool is basically by National Instruments. So if you are already having any NI user account, then that will work. We need to fill these brief details, and then when we click on this create account, so one validation email is sent to the email ID which we fill here in the email address. So after validation of that email, so by clicking on the validation link provided in the email, so our account will become active. So as I am already having my account, so I will not create another account, so I will directly log in into my account. So I am having my account with this email ID, so I will log in into this to start using this particular Multisim live circuit simulator. So when we log into this, so we'll have this type of home screen. So I will first go through various options on this page, then we'll explain actual circuit simulation using this tool. So first thing is that what are various features of this tool. So let me click on this. So this page shows various features of the Multisim Live simulator. So this is a way in which we can expand the Multisim experience. So Multisim is a standard software for desktop, so which almost every college is having this particular package for the simulation of circuits. So Multisim Live is the online version, which has been supported by this, National Instruments for online practice. So no basically download or no installation is required. Directly by just creating the username and password, we can start using this. So this is a very good feature of this, that we do not need any type of installation. So this particular tool gives user a feel of the multisim, standard multisim. It allows users to take the same simulation technology used in academic institutions and industrial research today and use it anywhere, anytime on any device. So this is again a significant feature that we can use anywhere, anytime on any device, provided we have the device with internet connection and we have a latest, we can say, the browser. So then it can be used anywhere. Then second major feature is we can create circuit schematics on any platform. So Multisim Live is accessed through a browser. So if we have a standard browser, latest browser, then we can easily access this Multisim Live circuit simulator. And this Multisim has many components. So there is a component library which is having many components, and we can start building our circuit, our design very easily. So no that type of component design is required. So the schematics which can be easily created, so those can be accessed and shared from the supported browser. So we can easily share our design with our fellow colleagues, our classmates, so with the help of this simple browser only. So this is the feature which I have already told, that we can have interactive circuit simulation with no installation. So there is no installation required. We need just username, password, and which can be created for free. So there is no application which is required to be installed. The next feature is same industry standard SPI simulation. So in this particular tool which is offered online, so we can have simulations which are industry standard. So there is no difference between the simulations which we do here when we do the same simulations in laboratories using the standard Multisim Live, standard Multisim software. So there is no difference. So we can have that type of standard simulations using this online tool also. So this is helpful for pedagogical environment. So we as teachers, we can use this the software for teaching our classes, theory classes as well as lab classes, and we can also get the feedback of the students when we are in showing the simulations real time in our classes. Then this is another feature that we can share our circuits with the community. So there is a Multisim Live community, so we can share our designs, or we can explore the circuits created by others. So this feature is also there. And also there is option of keeping our circuits private, but for private we need to have premium version of this Multisim Live. So the certain features are not available in this free online version. So there is online premium version also. So that has full features. And using this using this Multisim Live, we can have complete circuit teaching solution. So we can use this software for our teaching learning process, for designing our course material in different subjects like analog electronics, digital electronics, power electronics, operational amplifier-based circuits. So all this can be done using this single tool, Multisim Live. And another very important feature is that when we are using this Multisim Live tool through the browser, so what we are accessing is the latest version. So sometimes when we install the applications periodically, we need to update those applications to get the latest versions. So when the latest versions are uh, released, so we need to update our earlier installed applications, and we need to install those features. But when we are using this type of interface, when we are using the just username and password to access the software. So what we are using is the latest version. So all the features, the new features are installed in that version when we use that particular version. So there is no need to update or upgrade or reinstall. So these are the advantages of using this type of tool. So this is another feature that there is another tool which is called Measurement Live. So we'll not go to that Measurement Live, but this Measurement Live and Multisim Live. So these are basically compatible. So we can shift our simulations from Multisim Live to Measurement Live. So these are the major features. So then next button here is the pricing button. So in pricing, so we'll see the difference between the free version and premium. So there are certain features which are not accessible in the free version. So these are the various features which are accessible. So using these features which are there in free version, so we can easily do our basic experiments which we have to perform in labs. So we can analyze our circuits which we teach as part of our syllabus. So this is more than sufficient for basically exploring the circuit design. But again, if we want to go for the say all features, then definitely we need to subscribe this premium version. So it's up to the user whether he or she is satisfied with the free version or they want premium version. Then let's go to this third button, which is basically circuits. Under circuits, again, we have various options. So let's explore these one by one. So first thing is my circuit. So in my circuit, so whenever we as a user create any circuit and we save the circuit in this login portal, so those saved circuits will be available in this my circuits folder. So we can consider that all these links under the circuit. So these are kind of different folders. So different collections having circuits created by ourselves or by other users. So under my circuits, the circuits will be there which have been created by the user itself, and using this my circuits folder, we can see all the circuits saved here. And if we right now, you can see here that I have saved 3 circuits here: half adder, full adder, and half wave rectifier circuit. So if I click on any circuit, so I will get some more details. So when I created this circuit, okay, so this circuit has been created 2 months back, and 2 weeks ago I again edited this circuit, and 2 months, 2 weeks ago I created this circuits, and last modified, I just modified it 28 minutes ago. So we can have tags, all those things, and we can write our description in this particular portion. So if I now click on edit, so I can change this description. So once I have the circuit, so I can edit detail, or I can open the circuit and I can edit the circuit. So all these things are possible, and we can share the circuit using these various options. So social media compatibility is also there, and so we can have add comments for the circuit. And here, this particular page also shows the related circuits which may be useful for the user. So we can access these related circuits designed by other users, and we can have we can explore their designs also. So Mm, Here it also shows some type of the metrics, like how many users have marked this as favorite, or how many times it has been copied, how many times it has been viewed. So these matrices can also be there. So this is about the my circuits tab. Now let's go to my favorites. So here, whether we are on my circuit tag or my favorites option, so here you can see we get the most popular tags. So this shows the popular tags assigned by various users for different circuits. So this way we can get some idea about what type of circuits are there in the Multisim Live. So if I mark any circuit as favorite, so then that circuit will be available under this my favorite tab. So let's try this. So if say I mark this full ladder circuit as my favorite, so let me open this. Say I am marking this as favorite. Okay, so now let's see under my favorites. So that circuit is available under my favorite. So it's not only that I can mark only my circuits as favorites, so I can mark circuit explore designed by other users as favorites, and those will be available here. My favorite contains that collection. Then my groups is the option for joining the group. So currently I am not part of any group, so it's not showing anything. So now here we can see different groups, and or we can create our own groups, and then we can have various groups under the setting. So now let's go to this public circuits. So basically, these public circuits are the circuits which are designed by other users, and these are available to all the users which are using the Multisim Live this tool. So whenever we are using the free version, so whenever we save the circuit, so that circuit will be saved as a public circuit. So our circuits will be available to all users. So if we want to save our circuits as private circuits, then we need to have the premium version. So here we can see that there are different circuits which are there. So here we can see the count. So we are seeing the page one of around 1,52,000 pages. So we can see that if we count these circuits, so 1, 2, 3, 6, 9. So 9 circuits are shown on one page. So if we multiply this number by 9, so we can see the count of the circuits which are available on Multisim Live for the exploration. So we can open any circuit. Now, say I open this circuit. So then we can see this circuit. So this was created 5 years, 9 months ago, last modified 3 years ago. So it is having tags, register, DAC, ADC, so that type of thing. So circuit description is there. The circuit uses a resistor ladder to show the basic construct of digital to analog converter. Arbitrary voltage sources are used to simulate count upwards. So this type of thing is there. So this is the discussion or the comments related to the circuit. So this has been marked as favorite by these users. Then it has been copied by these users. So then this is shows the groups which are accessing the circuit. So these different matrices are there, and even we can copy the circuit and we can save in our own portal. So if I say mark this as favorite, then now the circuit will be available under my favorites. So this circuit is there, and I can start exploring the circuit. So when I click on this circuit, so then I can save a copy of the circuit as my own circuit. So I can open the circuit, then if the components used are available in free version, then I can easily edit the circuit, and or we can copy the circuit and then we can edit the circuit, and we can do modification, or we can explore see the working of the circuit. So now I again go to this public circuits tab. So here I can you can see that so around 1,50,000 pages are there. Then each page is containing the 9 circuits. So we can roughly count that there are around 15 lakh circuits which are there. So how to search these 15 lakh circuits for the desired circuit? So in this Multisim Live, we have these tags. So if we click on any particular tag, then only the circuits which have been saved by using those tags, so those will be visible. So like I have clicked on this common emitter tag. So I'm now seeing particular this tag. So here no results are found for the following search. So what if exact common emitter name is not there, but it will show the circuits which are having similar names like common emitter amplifier, what a plot of common emitter VGT amplifier. So this type of different related circuits will be shown. So if I am now searching with respect to common emitter amplifier or common emitter tag, so I am now having only 174 pages. So this way we can narrow down our circuits, or we can use this button for searching specific circuits. Instead of tags, we can also search through this ladder. So like here it is not showing any circuit here. Let me, okay, so I have to first clear this manometer, I think. Okay, now when I'm searching for adder, so I can see various circuits which are related to the term adder. So now I can see that I am having around 1900 pages having different circuits. So this way we can search our circuits, and if we find any circuit of which is useful for us, then we can save a copy or we can mark that circuit as favorite, and all those things can be there. Okay, then next button is the reference circuits. So when we click on this button, reference circuits button, so here we can see what we mean by the reference circuits. Reference circuits are the public circuits chosen for their reuse potential and great documentation. Use these circuits when looking for a new ideas or design documentation. So these are some of the circuits which are basically marked as reference, which are maybe having some unique features. So we can also search for these reference circuits when we are searching for the circuits. So here we can see that we are having only 4 pages related to these reference circuits. So we can easily explore these 4 pages, and we can search our circuit of interest first in reference circuits. Then if that is not there in reference circuit, then we can search in all public circuits. Okay, then let's see this groups. So groups are an easy way to join up with your friends and co-workers. So if you cannot find your group here, you can create one you are interested in. So here, this is the page to create any type of group which we want to create, or if we want to join a group, so we can have that type of search here. Okay, now let's go to this next button, resources. So here resources, first option is get started. So basically this step get started page shows the steps to create our own circuit. So these are various steps. So how to create the circuit, create multisim live circuit, filter. So that is the motive of this page. Then step by step it explains the basically procedure to design the circuit, and then to see the simulation results, then how to save the circuit, how to collaborate with community, how to add our circuit to the group. So these different options are basically explained in a step-by-step procedure here on the get started page. So any user can follow the steps, and they can get the basic feel of the this Multisim Live tool. Then we have this particular option which is named as help. So this help contains basically various resources which we can follow. Dear participant, just give me 1 minute. Okay, just let's again continue. Okay, so this is the help resources. So we can find documentation in detail. So we can have here, we can go through a tutorial. We can go through different features, options which are there in the Multisim Live. So these documentation topics are given here. So related to schematic, we can find here. The schematic is where you place and wire components and add simulation probes. So what are different options here? What are their uses? How to find that particular detail of any step? So we can go through these for sub details, and then we can get familiar with the various features of the Multisim Live. So these are various features under say this particular palette or the sidebar, which just we'll see after some time. Similarly, we can search for the simulation option. So there are a number of simulation types which can be used to analyze a design. So what are those simulation types? What is the meaning of those simulation types? So those details can be found here. So this way we can explore this help resources to basically find an answer to our any type of doubt or any type of our query. So we can search it here in the help. Then we have this idea exchange option. So here we can see that this is basically a kind of can say the network where different users post their ideas or they discuss the ideas. So we can here see that we can get hot ideas, top good ideas, or most recent ideas. So we can sort this using various headings, or we can sort using this status new in development, so that type of thing. So now I clicked on just most recent ideas. So here ideas by different users which they have posted here, so they can be seen. So further this can be explained. So this is a basically platform to exchange idea. Okay, so let's again go to these resources. So we have this support forum where we can get the support from different users. So if we are having some difficulty here, so we can have, so basically here if we see, so we have different options here, the board, documents, users, community. So we can select a particular option, and then we can start using these different forums which are there. Okay, so let me close this. So these are just various points. So FAQ is also there, so we can also visit this to get answers to some basic questions. So we can go through this and we can get some idea of the most frequent basically questions which has been asked. Okay, so these are the various options and their brief details. So now let's directly go to the creation of circuit. So to create a circuit, so we need to click on this create circuit. So when we click on this create circuit, so this type of button is there. Just participants, I will be back. Just give me 1 minute. Sorry for the inconvenience. Actually, I'm sitting in my office, so there was some visitors. Okay, let's continue for this simulation of circuit. So this is the window which we land in when we click on this create circuit button. So again, let's see what are various features here. So as in our physical lab, so when we want to say design circuits, when we want to build circuits, so what is the basic requirement? So first thing is that we need various components. So if we want to design a circuit, develop a circuit, then we need equipment or components to build that circuit. Then once we have the circuit, then second thing is we need various measurement device to measure the signals like current, voltage at different points, and we want to see different characteristics of the circuit. So if now we are developing our circuits in online mode, then also we need certain components, certain measurement devices. So in Multisim Live, basic components are available as component in these component libraries, or and some measurement devices are also there. Signal sources are there. So I will explain these different options which are available here. So I will be going through the very basic features. So once you are familiar with these basic features and how to basically build some basic circuits, then you can follow the same steps to create your own advanced circuits, or some say we can say the complex circuits. Okay, so let's explore what are various components or measurement devices are available in this Multisim Live. So here, if I click on this, so this is basically button which is named as analysis and annotation. So if I click on this, so I will get these different options. So this is a voltage probe. So this is a kind of probe which can be used to measure the voltage. Similarly, this is for current, this is for voltage and current. So then if we are measuring a voltage, then many times we need to measure voltage between 2 points. So second, one side of that particular link will have this particular voltage probe connected to that, and the other side will be assigned this voltage reference if we want to measure the voltage between two particular points. If we are using only this voltage button, then it will measure the voltage with respect to ground. Then this is for text annotation. So if we want to insert some text, then we can use this particular option. So this digital probe is there to measure the digital, we can say the output, whether we are getting 0 or whether we are getting 1. So that can be measured using this digital probe. So this first option contains various probes to measure the voltage or current or for annotation purposes, right? So then let's go to the second option. This second option has the name schematic connector. So here we can see that we have these three types of different connectors which can be used while designing our circuit. So we can use ground connector. So if you want to connect the ground to the circuit, that can be selected from here. Like if I click on this, so then this particular ground option will be selected, and it can be placed anywhere, and or it can be connected wherever we want. Okay, so other options are connector and junction. So okay, so these are three options which are available in this schematic connectors option. Okay, so now let's go to this sources. Under these sources, we can see that we are having different options which can be used for our circuit. So we have AC voltage source, AC current source, clock voltage, clock current, triangular voltage, triangular current, and similarly many other sources are there which can be used for our circuit design as per our requirement. Okay, then this link has some passive components like resistor, capacitor, inductor, potentiometer, fuse, transformer with one primary, one secondary, one secondary with center tap, one primary, two secondary. So these are three options available for transformer. Similarly, we have coupled inductor, we have the resistors which can be controlled by the voltage control resistor or impedance block. So these are the various passive components which are available there for use in free version. So whatever I'm explaining is the free version. So these are all options which are available in free version. Okay, then in this analog button, we have 3-terminal op-amp, 5-terminal op-amp, ideal comparator, 555 timer. So if we want to have circuit based on operation amplifier, then here we can select some of the components and then we can start developing our circuit. So here, if I now click on this op-amps, so you can see that we have these two op-amps which are given some numbers. So LM324A or UA741. So all these op-amps which are shown here, these circuits are basically generalized components. So if we want any specific IC or specific number if we want to use, then in free version certain these components are available by this reference number. So exactly now this UA741 IC operation is basically given here in this option. So these certain commonly used component numbers are made available in the free version and we can start using that also. Similarly for diodes, so we have PN diode, GNR diode or LED, so we can have these general diodes or some this if we want this particular diode 1N 4148, then we can also have this particular diode number which we can select from here. Then this button shows various transistors, NPN, PNP, NPN with 4 terminals, PNP with 4 terminal, NMOS, CMOS, FET. So all these different options are there. Again, certain component numbers are there. Like in NPN, we have these numbers which can be used, or we can in PNP we have this number. So that way, some component are there by number, so they have exact matching the behavior or the parameters are exactly those parameters which are expected from that component. Okay, now let's go to this next option. So this is indicators. So indicators, under indicators we have lamp, LED, 8 LED bar and buzzer. So these are various options which can be selected as indicators and these can be used in the circuits. Then next option is switch. So here we can see that what are various types of switches which can be selected and it can be used in our circuits. So there are standard switches or there are certain switches which can be controlled by using the voltage or the current. So those type of switches are also there. Then these are the modeling blocks. So basically the dependent sources. So we can have these various sources which are dependent on some voltage or current or such other type of parameters. So we can use these modeling parameters, so these control dependent components, and we can, if these are required in our circuits, then we can select from this option and we can start, we can use in our circuits. Now let's see this electromechanical. So this electromechanical option contains these various types of components, normally open relay, normally closed relay. So these are various relays. There are some types of machines like DC machine, permanent magnet, DC machine, bound field. So certain machines are there. This motion controllers are there. So if these are required in our circuits, then we can start. We can use from these options. Okay, linear regulator LM317. If this is required in our circuit, then we can also use this from this option. Okay, last option but not the least. So this option contains the components related to the digital lab. So here we can see we have various options related to digital lab. So first thing is digital constant. So digital constant means we know in digital we apply 0 or 1. So this digital constant option gives us that provision to apply 0 or 1. So we can, this is a kind of toggle switch. So if, on one side we have 0, in second state it gives us 1. So this is a kind of input for digital circuit. So we can apply 0 or 1 using this digital constant. Then this is AND gate. So if I click on this AND gate, so we can see there are different options which are available: 2 input AND gate, 3 input AND gate, 4, 5, 6, up to 8 input AND gate. So these are the AND gates which are available. Similarly for OR gate, we have from 2 input to 8 inputs. Then NAND gate is also there. NOR gate is also there up to 8 inputs. XOR gate is there up to 8 inputs. XNOR gate is there. Then we have this buffer circuit, and the last is inverter NOT gate. So these are the various components which are available in free version. So here we can see that although we are having basic gates and this digital input, but we are not having the flip-flops or the counters. Those types of components are not there in the free version. So if we want to use those type of components, then either we need to design from these basic gates. So flip-flop or counter we can design using these basic gates, or we can access the circuits designed by other users available as public circuits, and then there we can at least see the working of those type of circuits. I will demonstrate that also when we will be building digital circuits. So these are the various options which are available in our this component library, or we can say the equipment library. So now let's use some of the components and let's design our first circuit. Say I now want to design a circuit to verify Ohm's law. So then what is required in Ohm's law? We know that if we want to verify Ohm's law, then we need a voltage source, and we need to connect a resistor across that, and then we can measure the V and I, and then we can plot, and we can get the that relation V is equal to IR using this. We can verify that relation. So let's first select one resistor. So I'm selecting one resistor. We can place this resistor anywhere. So when I place here in this particular window, so this window is there to develop the circuit. So here we can see that there are different options. So this cross is there to delete. Now if I want to rotate, then I can click on this button, and this is to make. So if I want to place another resistor, so then I can click on this, and I can copy paste. So this button is there. Okay. Now this is option to basically toggle flip the resistor. So in case of resistance, this flipping is not much visible, but in other components this will be more visible. Okay, now we are having these two basically indicators. So R1, here we can change the name of the resistor. We can write any name to the resistor, like say if we want to use this resistor as load resistor, then we can write here as load. From here we can change the value, so we can directly write any value here, or we can drag this particular slider, and we can select the desired value of the resistor. So this is the way to change the various parameters. So now another parameter which we need for this verification is the DC voltage. So this battery is required. So I'll play this battery here. Like now, if I click on this flip, so we can see. Okay, so here we can see that when we click on this flip, so this direction of the battery is getting changed. So we can use these different options. So this is again DC source. So now these are two loose components. I need to connect these components. For connecting these components, we use connecting wires in our physical lab. Similar to that, so we need connecting links if we want to connect components in this Multisim Live circuit simulator. So there is no separate connecting wire available in this component list. So if we want to interconnect, so just take the mouse icon on any particular end, and here then we over our mouse over the terminal, then this type, at some point this type of you can say the icon will be available. So this icon is there to show the start of the connecting wire. So when this type of icon is there, press the mouse button, and we can have this type of connecting wire started. And when we want to release that wire at any particular point, So we need to take our mouse at the other terminal. So whenever there is possibility of connection, so it will show this type of pop-up. So now if I click here, I click the left mouse button, so it will form a connection link. So here we can see that this connection link is there. Now I need to connect this side of the resistor to the other side of the battery again. So I will basically move my mouse over the terminal. So at some point, so we'll see that other type of symbol will be there. Yes, this type of symbol is there. So whenever we want to make a bend, so we need to click at that point, so it will form the bend. So now here we can see that we have connected this battery across this resistor. So this is a 5-volt battery connected across 1 kilo ohm resistor. So now I also need to connect the ground to this circuit. So say ground is connected here. So when this voltage is applied, so current will flow in this circuit, and there will be some voltage drop across this resistor, right? So to measure the voltage drop across this resistor, we need to, in physical lab, we connect the voltmeter. But in this particular online version, we need to connect the voltage probe. So we'll go to this probe section. So I will select the voltage probe. So then that voltage probe need to be connected. So I will connect voltage probe here at this point, right? So now I want to measure voltage across this resistor. So if I connect only this probe, then this probe will show the reading with respect to this ground, right? So what if I want to measure across this resistor? So then I need to have a voltage reference. Voltage reference I will connect to the other side of this resistor. So now this voltage reference has also been assigned. So and here you can see that it has been written as reference 1. So okay, let me connect at some lower point so that it is reference 1 is visible properly. Okay, so if I now connect here, so we can see that it is reference 1, right? So now I need to assign this reference point to this voltage probe. So clicking on this. And so if I click on this, so here in the sidebar we'll have details of this particular component. So here you can see that when I double clicked on this particular component, so this automatically this type of detail in window pane opens. So here at this particular point, we can see that it is written as voltage reference. So I need to, by default, voltage reference is ground. So if I need to change that ground reference voltage point, so then I need to select that. So here REF1 we have assigned attached, so we need to select that reference point from this particular window. So now when we select this voltage reference as reference 1, so now this probe will show the reading with respect to this point, right? So this is a very important point that you need to assign a particular reference point while measuring the voltages. Okay, another parameter which will be measured is the current. So we need to select the current probe. So connect this current probe can be connected anywhere because in series current remains same, so we can connect anywhere in this loop. So as the current this particular probe is connected in series, so there is no need of reference points. So only single this current probe is sufficient for measuring the current. So now our basic circuit is completed. So now if I want to run this circuit, then I will click on this play button. So first thing is that we need to develop the circuit. We need to interconnect various components to develop the circuit, and once we have the circuit, so then we need to simulate that circuit. For simulation, to run the simulation, we need to click on this play button. So this is there for basically run simulation. So when I click on this, so here you can see that this time starts and our simulation has started, and it is this ammeter and voltmeter are showing some readings, right? So here if you see the 5-volt battery was applied, and this voltage reference is shown as the 5 volts. So the whole voltage, because there is no other component, so whole of the battery voltage is dropped across this load resistance, right? So 5 volt is shown. So now current here we can see that it is 5 milliampere. Okay, so V is equal to IR we know, and I will be V upon R. So V is 5 volts and R is 1 kilo ohm. So I V upon R will be 5 milliampere. So that value is shown here. So now if I want to change the voltage, so I will click on this particular 5 volt option and I can drag this option, this slider, and I can change the voltage, right? Okay, so here we can see that as we change the voltage accordingly, this battery voltage accordingly, this current and the voltage drop across load resistance varies, right? So, but because there is only one resistor, so the voltage is shown. Voltage across this load is shown equal to basically this 6.2 or the voltage, the battery voltage, right? So now once we have the circuit running, so now say we want to plot the uh, VI characteristics, or we want to plot the curve for Ohm's law. So what we can do is, so we can stop the simulation and we can again go to this. So we can start taking readings from say 1 volt. Okay, say we want to take readings from 1 volt. So this is 1 volt. So when we have changed this, so we have start simulation. If I run the simulation again, so I will see that the current is 1 milliampere and the voltage is voltage across load is again 1 volt. So we can click on we can open a particular Excel sheet, and then we can make columns as in our physical life we record our readings. So here also we can uh, record our readings. So for this is 1 volt, the current is 1 milliampere. So we can enter that voltage. It's in say volts, right? Say current is in milliampere, right? So when voltage is 1, current is also 1 milliampere. Okay, and then say now I change this voltage to say 2 or 1.5, and current will also again change to 1.5. Right. Similarly, from our basic knowledge, we know that here, then if I change to 2, then current will also change to 2 milliampere. So this way, because this is a very simple circuit, so values are predictable. So we can enter our desired number of readings here. So what is advantage of this type of entry is that generally in physical labs, after taking the readings, we plot the graph. So if we are taking the readings in this particular Excel sheet, then we can easily plot the graph. So we have say these readings. So now say I want to plot. So then I will go to these plots. So where are these plots? Under insert. So okay, under insert. So I will select the line chart basically. So this type of line chart here we can see that with respect to our reference point, we can have values of voltage and current displayed here as separate graphs, or if we want to see voltage versus current, then we'll need to select this type of graph. Okay, so here we can see that it is voltage versus this current graph. So we can have this type of graph directly plotted here in this particular Excel button, and then we can copy this graph and we can place in our practical file. So that type of uh, recording and plotting can be easily done using the Excel sheet when we are using taking readings from this multisim probes. So here, so this is a very basic circuit which can be simulated using this multisim live. So and then further we can save the circuit. So we can name our circuit. We can say name the circuit as Ohm's Ohm's law, and we can then save the circuit, and it will be saved in our My Circuits tab, but it will be available as private public circuits also. And using this option, this circuit can be exported, so we can export the schematic image, graphic image, graphic data. Okay, so let me show this waveforms option. So many times we are also interested in seeing the waveforms. So in this Multisim Live, so we have connected these probes, so we can see these waveforms by clicking on this grapher. So if we click on this grapher, so then here we are basically this grapher option is there to see the waveforms which are basically shown or the which are produced by these ammeters or voltmeters. So here we can see that the voltage value is 2 volt and the current is 1 milliampere. So when we click on this, voltage axis has been shown from 4 volts to 6 volts. So but our voltage here is 2 volts, so it is not showing here. Similarly for the current, so it is shown from 4 milliampere to 6 milliampere. So but current is 2 milliampere, so it is not coming into this. So for that, so what we need to do, so we need to change these ranges of the these axes. So minimum it has been shown as 4 volts, so we can select say minimum as 1 volt. So now here we can see at 2 volts we are getting that voltage waveform. But as this is a DC voltage, so there is a straight line. Similarly for current, it is from 4 milliampere. Say we select it from 1 milliampere. So now we'll be able to see the current also, because this current and voltage values are almost same, 4 milliampere, 2 milliampere and 2 volts. So these are overlapping, these two voltages. Okay, so this is the grapher option is there to see the waveform. So now if we click on split, so then we'll be able to see the schematic and the waveform side by side. So using this split option, we'll see the schematic as well as the waveforms side by side. So then we click on this graph, so we can change certain parameters of the graph using these various options available here. Similarly, when we click on any component or the circuit, so then various options which are available, which can be changed or which can be analyzed. So those are automatically shown here in this side window. Okay, so again, this button is used to stop the simulation. So this is the very basic circuit of Ohm's law. So any question up to this point? If there is any question from any of the participants, so then you can unmute yourself and you can ask that question. So otherwise, I will move on to the some more circuits. Any quick question from any of the participants? Okay, so if there is no question, so let's move further. So here I have shown only one resistor. So now let's develop a voltage divider circuit. So let me delete these various components. So again, I will start from the basic components. Okay, so now in voltage divider, we basically connect two resistors. So let's, this is the first resistor. I think let's select the second resistor. So this is the second resistor. So, and I'm changing say value of 1 to as say 5 kilo ohm. Right, so one is 1 kilo ohm, second is 5 kilo ohm. So again, this battery is there. Say let's say this battery is of 10 volts, right? So now let's again connect the connecting wires. Okay, so this first connection, and then this is the second connection, and then this is the third connection. So 1, 2, 3. So we have made 3 connections here. Again, let's connect the voltage probes across resistors. So first I want to say make the voltage across this resistor. So voltage probe for this and voltage reference for this, right? So PR1 is name of the voltage probe and reference 1 is the reference for this. So I need to assign this reference to this probe. So voltage reference 1 is assigned to PR1. So when we click on this, automatically only the options for this probe are shown here. So now let's connect voltage probe across second resistor. So here you can see that automatically the color has been changed. So by default, it will this tool will use separate colors and separate names for the different scopes which we are using. So here we can see that by default it has been named as PR2 and the reference has been named as reference 2. So I need to assign this reference to this particular probe. So now this volt PR2 will be showing voltage across this, and I need to connect the ground. So ground is connected here, right? And also we need to measure the current. Say current is measured at this point, right? Okay, so now this is a kind of voltage divider circuit. So let's simulate this circuit. So if I start simulation, so we can see that this 10 volt is divided now across these two resistors. 1.66 is divided across this, and then 8.3 is divided across this. Because this is the resistance value is more 5 kilo ohm, so it will have greater drop. Say let's say make this as 2 kilo ohm. Accordingly, this drop will change. So this is 1 kilo ohm, this is 2 kilo ohm. So 2 kilo ohm resistor will have double the drop of this particular 1 kilo ohm. Right. So now if I change the voltage, so here we can see. So if I change the voltage from 10 to say let's say 20. Okay, so accordingly this voltage drop voltage will be changed, right? So we can also see the waveforms for this. So voltage is from 6.6 to 13.3 and current is 6. Okay, it's one more point. So if I change the voltage value, so accordingly current will change, but the current will be same through the series connection. So this current will be flowing in the circuit. So voltage will change, also the current will change accordingly. Right. So now let's see the graphics. So voltage is from say 3.3, starting from 3.3 and second is 6.6. So by default range is from 1 to 9. So both voltages are shown here, right? And about current is 3.3. Okay, this current is because voltage 3.3. So again it will be overlapping. So let's change this to have some different value. Okay, I need to change this resistance basically. Say I'm making it as 5 kilo. Right, so now voltage is drop process is, let's make this some standard value, say 20. I'm sliding this. Okay, or we can enter by here. So 20 across this is 14.2, across this is 5.7, current is 2.83. So now let's see the graph. So this is showing from 1 to 9. So this 14 value is not visible. This blue color voltage is there. So I need to change the axis, right? Axis range. So instead of 1 to 9, say I'm making 1 to say 20, right? And current is 1 milliampere to 2 milliampere, but here in the 1 to 2 here current is 2.8. So current is not visible here. So again, let me change the value for current. So instead of 2 milliampere, say I'm making 5 milliampere. Now here we can see all three different signals which are shown in this waveform window, right? Because all are DC values, so only straight lines are there. If we are using some, say, this particular type of thing, AC voltage or other type of voltage, then accordingly we'll see the waveforms here in the grapher window. And we can then further analyze these waveforms, or we can save these waveforms for our record purposes, right? Okay, so this was the second circuit, voltage divider circuit. So now any doubt or query related to this voltage divider circuit from any of the participants? Okay.
Excuse me, sir. ये PR1 and PR2.
Yes.
Yeah, we need to give reference with respect to RF1 and RF2.
Okay, ma'am. Basically, ma'am, whenever we have to connect the whenever we have to measure the voltage, so we basically measure the voltage across the component. So to measure the voltage across the components, we need the two terminals. As in our physical lab, we connect the voltmeter across that component, so we connect the positive, negative, that type of configuration. So here, whenever we select any voltage probe, so we get the one terminal, right? So that one terminal we can connect on one side. Say I want to say across this battery, say for example. Okay, so by default, it will show the some heading here. So this PR1 is basically the default name for this probe. So we can change this name to our desired name. Say I want to change this as voltmeter, say 1, right, like that. Okay, so it is not allowing. I think space is not allowed or something. Yeah, space is not allowed. So we can rename basically these different voltage, these probes, right? And the second thing is, if we want, we do not connect any reference point on the other side. So then automatically that probe will measure the voltage across with reference to ground. So here I have not connected any reference point this voltage probe, so it is automatically showing as ground. So now if I want to measure across any say particular 2 points, then I need to select the reference point. Then I need to attach that reference point somewhere, wherever we want to measure that voltage. Say I want to measure between now this point and this point, or I want to measure between this point and this point, right? So I will connect the reference, but this reference probe there, and then I need to assign that reference to particular voltage probe. So if I now want to assign this reference 3 to this, then I will click on this voltage probe, and here instead of ground, I will select the reference 3. So that is the purpose of reference. So similarly, so any reference can be assigned to any probe. So just we need to select that probe, and we need to select the desired reference point.
Okay, sir. Thank you, sir.
So whenever we connect, it will not show the old reading. So here you can see it is showing like dash. It is not showing value. So when we run this simulation, so it will show the current value. And if we stop the simulation, it will record the last value. Here in this case, as the values are DC values, so much change is not visible. But in AC case, when we stop, so it will record the accordingly the instantaneous values at the time of stopping the simulation. I hope this reference concept is clear.
Yes, sir. Yes, sir.
Any other query related to this circuit? Okay, so now I would like to explain this digital circuit. So because this is the same tool can be used for the analog circuits, digital circuits, or operational amplifier circuits, and other various types of circuits. So these were the two basic electronic circuits. So now let's go to the digital circuits. So how to basically develop digital circuits and how to simulate those digital circuits. So let me delete these different options here. Or even we can directly go here and we can select the new file. So I'm changing the same file. Okay, so for developing digital circuits, we need to select the digital components which are available here. So let's first make the say we want to measure the truth table of say AND gate, right? So in most of the labs, the basic experiment first is to measure to verify the truth table of various gates. So for that, I selected one AND gate. So to measure the truth table, what is required? So we need to apply two digital inputs. So and we need to change those values 0 to 1 or 1 to 0. So we need to apply all the possible combinations, and then we at the output we need to measure whether it is giving us 1 or 0. To apply the inputs, so we need to select this digital constant. So first digital constant for one input. So I'm connecting here the one input, and similarly the second input will have the second digital in this digital input source. So I'm connecting the second input. So now to measure the output in digital circuits, we generally use the LED. So similar to our physical lab, so we can have the LED, and that LED will be connected at the output of the AND gate after class. So ground will be required to connect it. So now this is the complete circuit. So here we can see that it is showing as 1 or 1. So after completing this circuit, we can run the simulation. So as both inputs of this AND gate are 1, 1, so it is LED is glowing. So if I now want to verify the truth table, then I will apply all the combinations. So I can click on this, and this switch will get toggled. So now I am applying 0, 0, so output is 0. So if I apply 0, 1, again in AND gate we know output is 0. So if I apply again 1, 0, then output will be 0. So for 1, 1, output will be 1. So and LED will glow. Similarly, this the same can be seen in grapher, but if we want to see in the grapher, then we need to first connect the probe. So I have here not connected any probe, so graphical waveforms are not available. So let me stop this, and now let's connect the probes. Let's say I'm connecting this digital probe. Okay, so now let's again run and see what is shown in the digital probe. So the digital probe is showing the output as 1, right? So if we see in the split, so output is 1. So now if I change, say, this from 1 to 0, this output will go to 0, right? Similarly, if I want to show the input waveforms, again I will stop this, and I will connect more these digital probes. One probe for, say, this input, another probe for this input. Now if I again run, so here we can see it is showing the status or the value of all the probes. So here this DG1, this input is 1, so it is showing as 1. So we can see the same color is there. And also the same names are there. These names can be changed, like DG1, DG2 is there. So instead of DG1, DG2, I can change these names accordingly. These display names will change. Generally, we note the inputs by A and B. Okay, so inputs are A and B, and similarly, these names of the probes can be changed. So it can be changed as, say, I1, input 1. Similarly, this can be changed as input 2. This probe can be changed as, say, output, say, O. Right? So if now I run, so here I can see input 1, input 2, O. So those types of nomenclature will be shown here. So now two. Okay, so let me change. Actually, now only two. These two are visible. Two inputs are visible. This output is not visible. So let me. I think I have changed, deleted something here. Okay, let me again connect this. Okay. Yeah, now we can see that all three waveforms are visible. Right? And we can change these status of the inputs, and accordingly all these waveforms will get changed. So this is how we can verify the basic gates. So now let's say build a half adder circuit. So for that, let me again delete all these components. Let's start from the scratch. For developing, for building the half adder circuit, we need one XOR gate and one AND gate. So this is XOR gate, this is the AND gate, right? So we know, okay. So for half adder, we need to have two inputs. So both inputs will be digital inputs. So first input, second input. So both these inputs need to be applied to both these gates. So first input, say this input is named as A. So this input is named as B. So this input is also connected to this terminal. Now the same inputs need to be connected to the other gate also. So for that, I'll select this terminal from here and I will connect from here. So here, this dot basically shows the connector. So although this is crossing this line 2, so it is not connected here because I have not clicked here. So it is just overlapping. Similarly, for this second terminal, it will be connected here. So inputs are connected. Now to see the outputs, again we need LEDs. Two LEDs are required. Say this is LED for this output, say some output. In half adder, we know that we have two inputs and two outputs. So outputs are named as sum and carry. And this is the sum output connected to ground. Now let's select the second LED to see the carry output. So instead of LED 1, say its name is carry. Output is shown here. Then ground is connected here, right? So now the circuit is complete, but we have not connected the probe. So let's connect the probes also. So this is say this particular probe PR1. So let's name this as S or the sum output. Another probe, say connected at this point. Let's name this as carry output. Here, say a probe is connected, and its name is A. And say in the second probe here, again its name is B. Right. So 4 probes we have connected at different points where we want to see the waveform. So now let's run this. Okay, so I'll start from 0, 0. So in half adder, first of all, we have 4 options. So let's see in the split. So both the inputs are 0. Both the inputs are 0, 0. So outputs are 0, 0. So here in the probes also we can see sum and carry 0, 0. Inputs are 0. Now let's make A as 0, B as 1. So when A is 0, B is 1. So we can see the sum output is 1, LED is glowing, carry output is 0. The same can be seen here in the waveform. Sum output is at level 1, carry is at 0. This A input is 0, B input is 1. Now let's make this as 1, 0. So again we can see sum is 1, carry is 0. And now when we make both inputs as 1, 1, so both the inputs are shown as 1, 1, sum is 0, carry is 1. So this is the desired truth table of the half adder. So this way we can design our circuits. We can see full waveform, full schematic, or full risk split, right? So this way we can have our designs and we can analyze these designs, and further we can copy or we can export these schematics or the graphic image or the graphic data. So we can export and we can save for our practical files, or we can, if we want to use say in our slides or teaching material, we can have these images or data from here and we can use. Okay, so this was the basic half adder. So any point of discussion related to this digital circuits? there can be one question that okay, so we can easily design basic circuits using these various gates, but for complex circuits, say for especially for sequential circuits, we need flip-flops. So in free version, flip-flops are not available. So either we need to first develop flip-flops using gates, and then we can build our circuits. Or the other way, which I will suggest, is that although we are not able to basically uh, we are not able to basically design our circuits using flip-flop, but if we go to public circuits, here we can search certain circuits made using flip-flops, or even if there are tags related to flip-flops. Okay, so it is not there. Say I write here flip-flops. Let's see what is searched in public circuits. So we can see that using flip-flop, we have these circuits. If we want to analyze 4-bit digital counter, then directly we can open this. And then if we click on this open circuit, it will get clicked in after 5 minutes. So we can have this circuit, and then we can start simulating this circuit, and we can have analysis of this circuit. Okay, so we can basically uh, open some circuits from the available in the public circuits, and then we can at least see their working, and we can analyze or explore the working of these circuits, which are using components which are not available in our free component library. So this is the way where we can explore circuits which are not using components which are not available in the circuit. So I think I will stop at this point. So further, if we want to design any type of a circuit, so the procedure is same, that we need to connect the various components, and we need to connect the various probes, and we can start simulation. I have not gone into the these different types of simulation, so I have used the very basic type of simulation interactive. So if you are more interested, then you can go to these other types, so we can get some more details related to these other types in the help given for this particular Multisim Live, and you can explore other features. It has so many features, so but I have explained some of the basic features. Okay, so any query or question related to this Multisim Live, so you are welcome to unmute and you can ask.